Dear students, so in last class we were discussing the non-existence of primitive roots in some cases. We already proved that the primitive root exists when m equals 1, 2, 4, p power alpha and 2p power alpha. Now here we try to prove that when m is not of the form 1, 2, 4, p power alpha and 2p power alpha, and for any integer a with a and m are relatively prime, then the non-existence of this primitive root, for the non-existence we have to show that a power phi m by 2 is congruent to 1 mod m, or a power phi m by 2 is congruent to 1 mod m. Here, note that m is not of the form 1, 2, 4, p power alpha and 2p power alpha. Why? Because in all of these cases the primitive root mod m exists. Okay. Now here suppose m is of the form. If m has the factorization, m equals 2 power alpha into p1 power alpha 1 into p2 power alpha 2 etc. ps power alpha s. Where pi, what is pi? Here pi is an odd prime. Pi is odd prime. And s greater than or equals 1. S greater than or equals 1 and alpha greater than or equals 0. Okay. Since m is not is of the form, m not of the form, m cannot be, m never becomes 1, 2, 4, p power alpha and p2p power alpha. Since m is not of the form 1, 2, 4, p power alpha and 2p power alpha, then come to the exponents. Here when alpha greater than or equals 2, when alpha greater than or equals 2, then s equals 1. Why? If alpha is greater than alpha equals 2, 3 or whatever may be, then if s is not equal to 1, then m is of the form, m is any of the form, sum of this one, 1, 2, 4, p power alpha, 2p power alpha. And if s greater than or equals 2, then either alpha equals 0 or 1. Okay. Now we have m has this factorization. So what is phi of m? Phi of m equals, so since phi is multiplicative, so it is phi of 2 power alpha into phi of p1 power alpha 1 into etc. into phi of ps power alpha s. Okay. Then, but a and m are relatively prime. That is by the choice of a and m. A and m are, it is already given that a and m are relatively prime. Then we wish to show that a power phi m by 2 is congruent to 1 mod m. So for let G be a primitive root mod p1 power alpha 1. G be a primitive root mod p1 power alpha 1 means G power phi of p1 power alpha 1 congruent to 1 mod p1 power alpha 1. Okay, 1 mod p1 power alpha. And you can choose k. Use k such that a power k congruent to, or a congruent to g power k, a congruent to g power k mod p1 power alpha. You can choose k such that a congruent to g power k mod p1 power alpha. Therefore, what about a power phi m by 2? A power phi m by 2 is congruent to g power k into phi m by 2. G power k into phi m by 2 mod p1 power alpha. Okay. But what is phi m? Phi m is already given that phi m equals phi of 2 power alpha into etc. into phi of ps power alpha s. So phi m by 2 equals, it is phi of 2 power alpha into phi of p2 power alpha 2 into etc. into phi of ps power alpha s all divided by 2 into phi of p1 power alpha. Okay. That will be t. So equals some t into phi of p1 power alpha. Therefore, a power phi m by 2, a power phi m by 2 is congruent to it is g power instead of k into, k into phi m by 2. So phi m by 2 is this one. So k into phi m by 2 is k into this one. That is t into phi of p1 power alpha 1, where t is k into all the remaining quantities. So a power phi m by 2 is congruent to g power t into phi of p1 power alpha mod p1 power alpha. Okay. Now we wish to show that t is an integer. Now listen, if alpha greater than or equals to, for alpha greater than or equals to, what is phi of 2 power alpha? Phi of 2 power alpha is 2 power alpha minus 2 power alpha minus 1. We know that when p is in prime, phi of p is p minus, or phi of p power alpha is p power alpha minus 1 equals 2 power alpha minus 1 into 1 minus, or 2 power alpha minus 1 or 2 power alpha into 1 minus 1 by 2. 2 power alpha into 1 minus 1 by 2, that equals 2 power alpha minus 1. Since 2 power alpha minus 1 is always even. Okay, it is even. Therefore, when alpha greater than or equals to 2 power alpha minus 1 is even, means phi of 2 power alpha is even. So therefore, according to this t, what is t? T equals t equals k into phi of 2 power alpha into phi of p 2 power alpha 2 into etc. into phi of ps power alpha is all by 2. Agree? But phi of 2 power alpha is even. Therefore, you can say that this t is always even. Therefore, t is even. Okay, t is even. So why? Because 2 divides phi of 2 power alpha. So t is even. So that is our first requirement. By t equals k into phi of 2 power alpha into etc. We already proved that phi of 2 power alpha is even. Therefore, this product must be even. Therefore, t is even. Okay. So when alpha equals 0 or 2, when alpha equals 0 or 1, then s greater than or equals 2. In that case, phi of p2 power alpha 2 is also even. Therefore, we know that t is an integer. Agree? So since g be a, what is g? G be a primitive root mod p1 power alpha 1. Listen, g be a primitive root mod p1 power alpha 1 means g power phi of p1 power alpha 1 congruents to 1 mod p1 power alpha. Enough. That is, therefore, g power phi of p1 power alpha 1 congruents to 1 mod p1 power alpha 1. Also, we have a power phi of m by 2. A power phi of m by 2. What is phi of m by 2? Is nothing but it is a power phi of m by 2 congruents to g power. Come on, what is phi? Phi of m by 2 is t into phi of p1 power alpha 1. It is congruent, alpha 1 mod p1 power alpha. Okay, mod p1 power alpha. Why? A power phi of m by 2 congruents to g power, come on, t into phi of p1 power alpha 1. But g power phi of p1 power alpha 1 congruents to 1 mod p1 power alpha 1. Therefore, a power phi of m by 2 congruents to g power t into phi of p1 power alpha 1 mod p1 power alpha 1. But g power phi of p1 power alpha 1 congruents to this one. Therefore, this congruence right side is congruents to 1 mod p1 power alpha. Agreed. So finally, a power phi of m by 2 congruents to 1 mod p1 power alpha. So in the similar way, we can show that a power phi m by 2 congruents to 1 mod pi power alpha I. Enough. Okay. A power phi m by 2 congruents to 1 mod pi power alpha I, where I equals 1, 2, 3, etc. Up to s. Okay. Now we prove a power phi m by 2 congruents to. Now we prove a power phi m by 2 congruents to 1 mod 2. How? So we have a result If alpha greater than or equals 3, we already proved the result. If alpha greater than or equals 3 and x be an odd integer, then x power phi of 2 power alpha by 2 congruence to 1 mod 2 power alpha. If x be an integer, then odd integer with alpha greater than or equals 3, then x power phi of 2 power alpha by 2 congruence to 1 mod 2 power alpha means there does not exist primitive root mod 2 power alpha. Okay. So here what is m? It is given m equals 2 power alpha. That is always an even quantity. So m is even. And with the a and m are relatively prime, that means a is odd. Okay, m is even. A and m are relatively prime. That should implies a is odd. Since a is an odd integer, then according to this argument, we know that a power phi of 2 power alpha by 2 congruence to 1 mod 2 power alpha. A power phi of 2 power alpha by 2 congruence to 1 mod 2 power alpha. But what is phi of m? Phi of m is phi of 2 power alpha into phi of p1 power alpha 1 into etc. into phi of ps power alpha s. Enough. So we have, that means phi of m equals this one means phi of 2 power alpha always divides phi of m. Phi of m is a multiple of this phi of 2 power alpha. So phi of 2 power alpha divides phi of m. Phi of 2 power alpha divides phi of m means what is phi of m? Phi of m is some k into phi of 2 power alpha. K into phi of 2 power alpha. Okay. Therefore, a power phi of 2 power alpha by 2, a power phi of 2 power alpha by 2 congruence to 1 mod 2 power alpha gives a power k into phi of 2 power alpha. Phi of m equals k into phi of 2 power alpha and a power phi of 2 power alpha by 2 congruence to 1 mod 2 power alpha. So you can combine, then a into, by combining these two, a into or a power k into phi of 2 power alpha by 2 congruence to 1 mod 2 power alpha. Okay, a power k into phi of 2 power alpha by 2 congruence to 1 mod 2 power alpha. That means a power phi of m by 2 congruence to 1 mod 2 power alpha. Why? Yes, 1 mod 2 power alpha. Why? A power k into phi of 2 power alpha by 2 congruence to 1 mod 2 power alpha. But what is k into phi of 2 power alpha? That is phi of m. Therefore, a power phi of m by 2 congruence to 1 mod 2 power alpha. If alpha less than or equals to, what happens? If alpha less than or equals to, so listen, if alpha less than or equals to, means alpha equals 0, 1 or 2. Therefore, this 2 power alpha is 1, 2 and 4. If alpha equals 0, 1 and 2, then 2 power alpha is 1, 2 and 4. And a power phi of 2 power alpha. A power phi of 2 power alpha. What is a power phi of 2 power alpha? A power phi of 2 power alpha congruence to a power phi of 2 power alpha congruence to 1 mod 2 power alpha. Okay, why? Because 2s is a primitive root of mod 2 power alpha. When alpha less than or equals 2, means alpha equals 0, 1 and 2. 2 power alpha is 1, 2 and 4. Therefore, a power phi of 2 power alpha congruence to 1 mod 2 power alpha. So, there are two results. A power phi m by 2 congruence to 1 mod 2 power alpha. A power phi of 2 power alpha congruence to 1 mod 2 power alpha. And when s greater than or equals 1, what is m? M has this factorization. Therefore, phi of m equals phi of 2 power alpha into phi of p1 power alpha 1 into etc. into phi of ps power alpha s. So, that can be rewritten as 2r into phi of 2 power alpha. Okay, 2r into phi of p power we proved that phi of p1 power alpha and p2 power alpha to etc. are even. So it is 2 of r into phi of 2 power alpha. Therefore phi m by 2. What is phi m by 2? Phi m by 2 equals 2 into phi of 2 power alpha. Phi m by 2 equals r into phi of 2 power alpha. Phi of m by 2 equals r into phi of 2 power alpha. That means phi of 2 power alpha divides. That means phi of 2 power alpha divides phi of m by 2. Okay, phi of m by 2. So we have a power phi of 2 power alpha all power. We have a power phi of 2 power alpha all power are congruents to 1 mod 2 power alpha. Agree? That means what is phi of 2 a power? That means a power phi of 2 power alpha all power r means a power r into phi of 2 power alpha congruents to 1 mod 2 power alpha. Okay, that means a power, what is r into phi of 2 power alpha? R into phi of 2 power alpha is phi of m by 2. That means a power phi of m by 2 congruents to 1 mod 2 power alpha. Agreed. So combine this, the third result. So combines these three, or when a, then the first three results, a power phi of m by 2 congruents to 1 mod 2 power alpha, and a power phi of m by 2 congruents to, or multiplying of these results, then a power phi of m by 2 congruents to 1 mod 2 power alpha into p1 power alpha into etc. into ps power alpha. Yes, thus there does not exist primitive root mod m when m is not of the form 1, 2, 4 p power alpha and 2 p power alpha. Okay, that's our conclusion.